Hello everyone, we are back with another maths, and this is gonna be geometry, the first video of geometry in my channel. So please support it, like and subscribe if you don't. Okay, Apollonius. Most of you might have heard this name the first time. Apollonius of Tyana was a Greek Neo-Pythagorean philosopher from the town of Tyana in the Roman province of Cappadocia in Anatolia. Okay, these informations are irrelevant, whatever. So the theorem that Sir Apollonius gave us was that, okay, the theorem was that AB whole square plus AC whole square is equals to 2 multiplied by the summation of AD square plus BD square. Okay, we draw two figures. One is an acute angle triangle and another is an obtuse angle triangle. Okay, so previously what we have learned that AB square, this is this right here, and in this triangle it's this, so it's equals to AD square plus BD square. We are talking about the triangle ABD. Okay, ABD, I didn't mention that, you have to mention it in your exams. So these two are the equations, and AC square, which is ACD, the triangle ACD here. So it's an acute angle triangle, as angle ADB is an obtuse angle triangle. Obviously the supplementary one should be an acute angle triangle that is less than 90 degrees. So if we add these two equations, then we get that AB whole square plus AC whole square. It's pretty simple. Now the right hand side, so 280 squares, 280 squared. Now 2 BD squares. Remember, the point D in these two figures are the medians. So that is the AD is the median. So D is the midpoint of BC. So BD is obviously equals to CD. So BD square plus BD square, 2 BD square, and BD is equals to CD. So these two cancel out each other. And 2 in common. This is the theorem of Apollonius, which he has explained, and it will be very handy in the upcoming exercises, especially 3.2 maybe, and 3.1 there are not many applications of this. So on to the next one, that is the variation of the theorem of Apollonius. So if any triangle is ABC, whether it's an acute angle or an obtuse angle triangle, I encourage you to do it with an obtuse angle triangle. In that way you can be much more sure about if this is only true to acute angle triangle or obtuse angle triangle. But acute angle triangles is much more simpler than obtuse angle triangle, but still you can do it if any of you wants to try it out. So according to the Apollonius theorem, we write this equation: AB whole square plus AC square is equals to 2 into AD square plus BD square. Now AB is equals to C, AC is equals to B, BC is equals to A, and the three medians are D, E, and F. Okay, so from here we can put the values like single letter values. So AC is equals to B square, AB square is equals to C square, and 2 multiplied 2AD square, that is 2D square here, right? AD, and BD is equals to half of A, like A by 2. So square and half of A is equals to A square by 2. So from here we can write it as multiply 2 to both sides. These two cancel out, and 2 into 2 4, and whole multiplied by 2. So from here we interchange the sides and subtract A square from both sides, so we get this, and divide 4 to both sides. So D square is equals to 2 multiplied by the summation of B square plus C square negative A square divided by 4. Similarly, we can write the E square is equals to this, and F square is equals to this. Now an easy way to remember this, remember D square is equals to this, right? D square. So what is D? D is this, and 2 into B square plus C square. B square plus C square, the median, two sides subtracted by the other side, that is on which the median is, and the divided by 4 is in everything. So that's how you can remember this theorem. Okay, another variation of the Apollonius theorem is this, like if the summation of the squares drawn on the medians of any triangle. Okay, so d squared plus e squared plus f squared is equal to these three right over here, and in the numerator there are 4 a squares, b squares, and c squares, and 1 negative a squared, b squared, and c squares. So ultimately it adds up to 3 a squared, b squared, c squared divided by 4. That is common. Okay, so pretty easy, and multiply 4 to both sides and exchange these two sides, and we get this. This will be very handy in exercise 3.1, which I will be covering in the next video, in the upcoming video, in probably 1 week. So stay tuned. Okay, the last variation we are gonna be doing today is this one. It's a simple Pythagorean theorem. A squared plus b squared is equal to c squared. Now add c squared to both sides, we get this. Again, we know that the value of a squared plus b squared plus c squared is equals to 4 by 3 multiplied by the summation of the medians, squares drawn on the medians. So we get this, and divide 2 to both sides, that is only c squared, and 2 by 3, and multiply 3 to both sides, that is 2 into d squared plus e squared plus f squared equals to 3c squared. That's it today. Thank you very much for watching the video, and don't forget to like, share, and subscribe my channel. Thank you, and have a good day to you all.